Hello everyone, welcome back to this series where we go over chapter 5 exercises from our PUS 325 investment course. In this particular video we're going to go over exercise or question number 6. So let's read the question together. The question says the stock of Business Adventures sells for $40 a share. Its likely dividend payout and end-of-year price depend on the state of the economy by the end of the year as follows. And then they are providing us with a table that shows 3 different scenarios: an economic boom, normal economy, and a recession. For each scenario, we have the dividend distribution and the stock price in case that scenario comes to fruition. Okay? First requirement, calculate the expected holding period return and standard deviation of the holding period return. All 3 scenarios are equally likely. Okay? So the main difference between this exercise and the exercise before is that we don't have the holding period return for each scenario. Instead, we do have the ending price and the beginning price per share. Okay, so the way I'm gonna do this, you can either apply your calculation for each scenario as a formula and then write it down, or you can do like what I'm about to do here, is that I've added 2 extra columns. So I repeated the same information here, as you can see: boom, normal economy, and recession, and I transferred all the dividend information and the price per share information. But I have added 2 more columns, one for the probability and one for the holding period return. Okay. Now the probability, as the question says, all 3 scenarios are equally likely. So from that, we know that each scenario's probability is going to be 1 over 3. Okay. So 1 divided by 3. In a decimal format, I'm going to write it as 0.3333. Okay, and that would be the same for all 3 scenarios. Okay, now the holding period return, we know the formula. Let me write it down. Holding period return is going to be equal to the ending price, let's call it P1, minus the beginning price, let's call it P0, plus any dividend distribution, all divided by the beginning price. Okay, so I'm going to apply this formula for each of the scenarios and write down my answer. So for the economic boom case, the ending price is going to be $50. So P1 in this case is 50 and P0 is $40 right here. And the dividend is $2. Okay? So I'm going to go to my calculator and run the numbers. 50 minus 40 plus 2, that will be 12, divided by the beginning price again, which is 40. That will give me 0.3, which is 30%. Okay, I'll do the same for the normal economy situation, but this time the inputs will be different. So P1 is going to be $43, 43 minus P0 is still going to be the same, which is this $40. So in my calculator, I'm going to type 43 minus 40 plus the dividend, which is $1 in this case. That will be 4 divided by 40 and multiplied by 100. That's 10%. Okay. And again, we'll do the same for the third scenario, which is in case of an economic recession. But P1 is going to be $34. 34 minus P0 is still $40, of course, so minus 40, plus the dividend this time is going to be 50 cents. So plus 0.50. That's going to give me minus 5.5. I divide that by the beginning price, which is 40, and then multiply that by 100, and I'll get minus 13.75%. All right. Now that I have the holding period return for each scenario, I can calculate the expected holding period return. So let's first erase this formula from here. Okay. And we'll go back to our equation. Expected return is going to equal sigma, the probability, multiplied by the return on each of the scenarios. Okay. So that means I'm going to say 1 over 3 or 0.333, whichever you want to write is fine, multiplied by 30%, okay, plus, again, 1 over 3 multiplied by 10%, plus, that second bracket was not necessary, plus 1 over 3 multiplied by minus 13.75%. All right. All you need to do now is just run the numbers on your calculator. So I'll open a bracket, multiplied by 30% or 0.30 plus multiplied by 0.10 plus multiplied by minus 0.1375. That will give me 0.87. Sorry, let me fix that. 0.08749, so we'll just round up, which equals 8.75%. Okay. I took a shortcut here. I would recommend you, as I mentioned in the previous exercise, to simplify each term on its own first, okay, and then add the 3 terms together, just to avoid making mistakes in your when you're transferring your numbers to the calculator and from the calculator back to your paper. A lot of students make a lot of mistakes when they are doing that. So the more steps you take, the better, to try to ensure that you avoid these kinds of mistakes. Okay. All right. So we've done the first part. So that means our expected return is 8.75%. Now we can move on to the second part of the first requirement. We are still working on part A, by the way, which is to calculate the standard deviation. Now, we've mentioned before that the standard deviation is the square root of the variance, right? So in order to figure out the standard deviation, I first need to calculate the variance and take the variance, take my answer's square root in order to get to the standard deviation, okay? And the variance is calculated as follows: sigma, probability of each scenario multiplied by the difference between the holding period returns on each scenario minus the expected return that we have calculated. Okay? To the power of 2. So we're going to take each scenario's probability, which in this case they are all the same. Each scenario has the same probability, 0.3333. So we'll say equals 0.3333 multiplied by 30%, which is 0.30 minus the expected return we already calculated here in the step before, which represents the mean. So that's going to be 0.0875 to the power of 2, okay, plus the second term is going to be 0.3333, which is the probability, multiplied by 0.10 minus 0.0875, okay, to the power of 2. And I'm gonna unfortunately have to continue my calculation in the second line and the following line. So the third term is going to be 0.3333 multiplied by the scenario's return, which is minus 0.1375 minus our expected return or our mean return, which is 0.0875 to the power of 2, and we close this. Okay. Now we're going to have to calculate. Again, I would advise to calculate each term. I would also advise you to calculate this part first and then multiply it by the weight or the probability. Okay. So we'll see. I'll open a bracket on my calculator, 0.30 minus 0.0875, close the bracket, and then raise to the power of 2. Okay, that gives me 0.045156. I'll multiply that by 0.3333, which gives me 0.0150. Okay, plus the second term. Again, we will do this part first and then we will multiply it by the probability. Okay, so I'll open a bracket, 0.10 minus 0.0875, close the brackets and raise all to the power of 2, and then multiply that by 0.3333. Okay, let me just double check. I got a number that is a bit too small. I'll redo that. 0.10 minus 0.0875 to the power of 2 multiplied by 0.3333. Okay, 0.000052. Okay, and then we add the third term, this part right here. Open a bracket, minus 0.1375 minus 0.0875, close the bracket and raise to the power of 2. we get 0.0506. Multiply that by the probability, and I got 0.01687, so I'm going to round that up to 169. Okay. Now I'll add these three together. 0.000052 plus 0.015 plus my answer. Okay. And this is what I got. 0.0319. Okay. Now, this is our variance, but this is not what is required in the question. What is required is the standard deviation. But because we know that standard deviation equals square root of the variance, so this is what we're going to do. We're going to say standard deviation equals square roots of my answer, because I still got it in my calculator, and that would be 0.17867, so I'm going to round it up. Okay, multiply that by 100, and I get 17.87%. Okay, which is going to be the answer to the first requirement in the question, requirement A. So now we have the expected return, and we have the standard deviation. Okay. Now moving on to the second requirement, requirement B, right here. Calculate the expected return and standard deviation of a portfolio invested half in business adventures, which is our stock right here, and half in treasury bills. And the return on the treasury bills is 4%. Okay? So now we're going to assume that instead of investing all of our portfolio into this specific stock, now we're going to create a portfolio that is 50% this stock and 50% treasury bill. Okay? So what would that affect, or how would that affect our expected returns and our standard deviation? So let's see. Part B, expected return. Let's call it C of the complete portfolio. That is going to equal, what do we need here? We need the weights and we need the expected returns for each of the components of the portfolio, right? So let me write that down first. The weight of the stock component equals 50%, okay, which is 0.5, and the expected return on the stock is equal 8.75%, and the weight for the treasury bill is also 50%, and the expected return on the treasury bill is equal, as it was given to us in the question, equal to 4%. Okay, so all we need to do now is multiply the weight of the stock by the expected return on that stock plus the weight of the treasury bill multiplied by the expected return on the treasury bill. Okay, and with that we get 0.50 multiplied by 0.0875 plus 0.50 multiplied by 0.04. Okay. Now let's calculate that. 0.5 multiplied by 0.0875. That would give us 0.04375 plus half of the 4%. Of course, that's going to be 0.02. Okay, so I'm going to add 0.02 to my answer in the calculator and multiply that by 100, and I'm going to get the expected return on the complete portfolio to be 6.375%. Okay. Now also we need to figure out the standard deviation on a complete portfolio. Okay. And I'll write it down as a formula for you as well. The standard deviation on a complete portfolio made up of two components: business adventures stock, 50%, and 50% treasury bill. Okay. So again, we also need the weights right here. We need those. But we also need the standard deviations of each component. The calculation is going to be the weight of the stock component multiplied by the standard deviation of the stock component plus the weight of the treasury bill component, or the allocation of the treasury bill component, and multiplied by the standard deviation of the treasury bill component. Okay? I already have the weights. We know that it's 50%, 50%. But now we need to also write down the standard deviation of each component. The standard deviation of the stock we calculated in the previous part of the question here. 17.87%. Okay? However, the standard deviation of the treasury bill is not given to us, but the book assumes that you should already know that the treasury bill component is considered a risk-free investment. And because it's a risk-free investment, there's no variance in the expected return, right? And based on that, we assume that the treasury bill has a standard deviation of 0%. Okay? So knowing that piece of information and going back to our formula, the weight of the stock component is 0.50 multiplied by 17.87 plus 0.50 multiplied by 0% equals, meaning that this part of the calculation is all going to go away, right? And we are going to be left with this part, right? So 0.5 multiplied by 17.87, and our answer is going to be 8.935%, which is the standard deviation of the complete portfolio. All right. That is a full rundown of the answer to question number 6. I hope that you found this video useful and informative. And I'll see you, inshallah, in the following exercise. Until then, take care.